Assalamualaikum and hello. My name is Muhammad Panafizi bin Muhammad Shawan Safari. My metric number is 08DJK22F1027. So in the video, I want to introduction for integration. So integration is introduced as the reverse process to differentiation. It has wide application, for example, in finding areas under curve and volume of solid. We can say that the integration of a function is to get the original version of the function f(x) from its derivative f(x). A definite integral is defined to be exactly the limit and the summation. The definite integral of a function is closely related to the antiderivative and indefinite integral of a function. The primary difference is that the indefinite, if it exists, is real number value, while the latter two represent an infinite number of functions that differ only by a constant.
What is application of integration? One of the use of integration is to find area. For example, a civil engineer might want to know the area of the piece of wood used to do form work to build an arc of a building. A fashion designer might want to know total fabric area needed to make curtain. Area between a curve and x-axis between range x equal a and x equal b. Hi, my name is Muhammad Iqbal Hakim bin Ismail and my metric number is 08TJK22F1055. Today I will present about integration to find area. So this is the example question of using integration to find area. Find the limit of the shaded region when y equals 0, x minus 1, x minus 5 equals 0, x equal 1, x equal 5. So the shaded area is integrate y dx with 5 as the upper limit and 1 as the lower limit, and then insert the y value, and then we expand the equation. So x cubed over 3 minus 3x squared plus 5x with upper limit 5 and the lower limit is 1. And then we substitute the equation with 5 and this equation with 1. And the final is we get minus 32 over 3 units squared.
Okay. Now my question is find the volume of the solid obtained by revolving the region M around the x-axis. Volume equal the integral x equal a to x equal b because we are revolving around and we are to across, so that why we need everything in terms of x, so it be our area in terms of x ds, and that area is the of one cross section. So this cross sections circle, we know the formula for that is pi r square. So our volume is going to be from x equal 3 to 7 because those are the area is pi r square, and we figure out what r is going to be in a second ds. Okay, this doesn't seem so bad. So we can see that there are a bunch of different sizes of circularities here, and those are changing as we move along the interval, but what's consistent is the height, is the radius of this. You can see that the radius is from the x-axis, which is the middle c. If we can draw a point in, so the x-axis all the way to the line which we can is equal the square root of x minus 1. So that height is y, which is the square root of minus 1. Therefore that's our radius, so it becomes the integral of from 3 to 7 pi r is the square root of x minus 1. no matter where we are in terms of s squared ds, and we just square it because the radius is squared. So this will be the pi can come out from the need to grow 3 to 7 of s minus 1 when we take something under the square root and square it the square just this separate s. And now we are ready to integrate its pi into s squared over 2. That's the integral of s minus s evaluate from 3 to 7, which will be pi into plug the 7 in first, so 49 over 2 minus 7 minus plug the 3 in 9 over 2 minus 3, and we get the pi into 49 over 2 minus 9 over 2 is 14 over 2 minus 7, 3 is minus 4. So this is, so minus 4 is 16 pi units cube.
So, lastly is the conclusion. So, in conclusion, there are many applications in which integration is used, whether it is to calculate area or volume. This allows engineers to design and create wonderful machines. Integration also help engineers to solve problems in the engineering world, and thus it open up a whole new level of engineering. So that's all for the integration. Thank you.